Mark Willman is extremely entertaining. If you saw Gary Greenberg, he is not the traditional speaker. He is more what I think is relaxed and worldly and has some opinion, which is really important amongst all the facts. But his real bio is Mark did grad work at IFA Minoa, and for those who don't know what the acronym IFA is, it's Institute for Astronomy, which is where we are right at this moment. On space weathering, on asteroids finding, a timescale of hundreds of MER. Now, MER is M-Y-R. Millions of years. That's something I had to look up because you don't use that expression very frequently. Millions of years. I'm only 72. My watch just went off. So hundreds of MER as opposed to another view with much shorter times, still under debate. He came to Maui 5 years ago to work on PAN-STARRS, which now we know means Panoramic Survey Telescope and Rapid Response System. For those who weren't here earlier, PAN-STARRS takes photographs of the night sky every night, right? 7 days a week. Okay. And it goes on to say, of course, looking for killer asteroids. Now, in the first talk, we talked about near-Earth objects. Near-Earth objects in that talk were related to satellites, right? The near-Earth objects that PAN-STARRS looks for are killer asteroids. So it's really important work, and we've seen a lot of science fiction movies regarding asteroids that are coming to visit. So just, and perhaps Mark has been involved in this, but PAN-STARRS has notably recently discovered the first interstellar asteroid. So please welcome Mark Willman. Thank you for joining us.
All right, good evening, everybody. Welcome to the IFA. And the topic tonight is the climate predictions that have just come out this month. This is a third in a series of talks that started last year. And the first one was last year in the spring regarding Trappist 1. There was this remarkable solar system discovered 40 light years away, probably the most remarkable one out of the several thousand extrasolar planets we've discovered now. And it has 7 planets. The remarkable thing about them is they're all Earth-sized. Nobody ever expected to find a system like this. They're around an M-dwarf star. And we discussed the details of that system, everything we know about it, and the possibility of habitable planets there that we could live on. The definition of habitable is if it's in the right temperature zone to have liquid water, to have water oceans like Earth does. If you're too hot, it's a Goldilocks zone. If you're too hot, of course, you have no liquid water. If you're too cold, it's frozen over. So you want that sweet spot like Earth. Almost guaranteed at least one, maybe 2 or 3 of these planets are in that zone. It's possible that all 7 of them are habitable because of tidal locking, which is where one side's facing the sun, the star, the other side, they're locked, like our moon is locked us. We always see the same face of the moon, right? If that happens, then you're going to have one side is baking hot, one side's frozen. But in between, at the terminator, there's going to be a sweet spot on that planet, a ring, an ocean ring you could have there. So because of that, it's possible you have 7 habitable planets strung out like pearls on a necklace. So that's a remarkable discovery. You had to talk about that. You can look it up. We were saying if you want to search for these archive talks, you can search for IFA Maui public talks, and you'll find the URL. So then, the conclusion of that talk well, we were discussing the various parameters, the gravity, the atmosphere, the possibility of water, and so on. And the main unknown turned out to be the atmosphere. So that led us to think about, what about our own atmosphere on Earth? And so I gave a follow-up talk in the fall about that. When the IPCC report came out, that's the Intergovernmental Panel on Climate Change. So they do this report every 4 years. And so October 17, they released the 4-year report. And it said we need to cap it at 2 degrees, the temperature rise. So far we've risen, since the Industrial Revolution in the mid-1800s, we've risen about 1.1 degrees Celsius. 1 degree Celsius is 1.8 degrees Fahrenheit. So that's right at 2 degrees Fahrenheit. We've heated up the planet 2 degrees already in the last century and a half. Now, this year, they did a supplemental report because they are getting quite alarmed. And the supplemental report dealt with the possibility of keeping the temperature rise to 1.5 degrees instead of going to 2. They're getting very nervous if we go to 2. So they think it's safe. If we can hold the temperature rise to 1.5, we will avoid the worst effects of climate change. However, so that's why they put out this extra report this year. They're trying to really goad governments into action. There's been no action. There was a big conference in 2015 by all the governments, many of the governments on the planet, and they agreed that we must hold the rise to no more than 2 degrees, and preferably to 1.5. Pretty much, I'll cut to the chase, pretty much nothing is being done. Nobody is meeting their commitments. Maybe 1 or 2, Sweden or somebody is, but nobody that counts in an large industrial nation. So, nothing against the Swedes, of course. So now, that report was just released this week, and it talks about the urgency of the matter. There were 2 other papers that came out this month. One talked about these tipping points. That's where you hit a feedback loop on like say the polar caps. The polar caps reflect a lot of sunlight, right? Because ice is very reflective. It's almost 100%. They reflect sunlight. But say in the Arctic, say that whole cap melts, then the ice is gone, and you have left blue ocean, deep blue ocean. That's very dark. It absorbs almost all the light. So now, the fact that you've heated up and melted the ice then causes you to absorb more heat. That melts more ice. You see how this is a feedback loop. This thing gets spinning around. It goes out of control. If that starts to run away, like a runaway train, then it doesn't matter at that point what humans do anymore. We could stop burning oil tomorrow, and the temperature will continue to rise to our detriment. So the scientists are getting very nervous about this because these tipping points are not known precisely at what temperature they will happen at. They're guessing. I mean, they're doing computer simulations and so on. They're taking their best guess, but it's just speculation. We've never been that hot before. We don't know when the polar caps completely melt. We don't know when the permafrost melts and all the methane cuts loose, a huge greenhouse gas, much more potent than CO2, which is our current problem. So there's half a dozen of these things that we're moving into unknown territory. So it's very dangerous, and the scientists are getting alarmed. And scientists generally like to try to stay objective and neutral and just present the facts. But they are now starting to get political out of sheer necessity. They're so worried about this. So our conclusion for that first talk was take better care of the planet we share. And I can't resist showing you one slide from that talk. These are the 7 planets that Trappist won. Now those are beauties. These sizes are very accurate. This is by the transit method. So you see a shadow. When the planet crosses between us and the star, you get a dimming of the light. And you can measure that precisely. That tells you the radius of the planet, how big a shadow you're casting. So they know these diameters are accurate. They also can determine the masses. So there's the radius. These are the radius in terms of Earth radius. That's like 9% bigger than Earth. Here's Earth for comparison, same size. Now look at Earth. They're almost all Earth-sized. I mean, very close. This is the smallest one, I guess. Anyway, I don't want to go into detail on this. You can look up these details. That's not our topic tonight, but it's in the archives. But we know both the mass and the radius, therefore we can determine the gravity. Now the colors here, that's artist rendition. That's speculation. We're just taking our best guess. We don't really know what they look like. But anyway, check that out if you like online. Okay, let's first talk about the data, the actual temperature record of planet Earth. And then I'll just briefly flip through a few consequences of the projected temperature rise. And at the very end, I'm going to make a political statement, which will be controversial, but somebody's got to do it. Okay, this is about the last 500,000 years of the Earth's temperature. So here's the time axis, and this is 0. This is now. This is current. Here's 50,000 years ago, 100,000, 2, 3, 4, 400,000. Back 500,000 years would be here. And then up the side, you have the delta temperature, the change in temperature from the current temperature. They're calling this 0. So this is hotter or colder, plus or minus degrees Celsius. And so you see that from the current temperature, we have in the past 500,000 years gone up to about 3 or 4 degrees hotter, and we've gone down to about 6, 7 degrees colder. So what you're seeing here, first let me tell you where these are from. This is Vostok Lake. It's a completely frozen over lake in Antarctica. So they drill out an ice core, and from that they can determine both the CO2 levels from the little bubbles of air left. So they can measure how much CO2 was in the atmosphere at that time. And they can see layers of ice, so they can determine by the thickness of the ice, the temperature, how fast ice was being laid at that time, laid down. So this is Vostok. Now this is another, I forget where this is on the planet, but it's a completely different location. This is some glacier somewhere. So the point of showing these two is for comparison, to show that this is actually a global effect. We're not getting local conditions here. This is the entire planet's temperature. And you can see they match perfectly as we go back, they're very close down to small details here like that. You can see these two match. Okay, that gives us good confidence. Here's a third measure of ice volume. Now they can tell that by how much of the planet was covered by ice at that time. And so I'm not sure how they measure the thickness, but they get total ice volume. And this is reversed from what you might expect. So this is low ice and high ice is downwards. That's because when it gets hotter here, you expect lower ice, as indeed you do see here. So this curve also matches the temperature record quite closely. Now, what do you see here? We see this pattern repeating. It's periodic. These are ice ages when it gets cold. And these are called interglacials, in between ice ages. We get a brief period of warmth on the planet, a brief period being 10, 15, maybe 20,000 years if you're lucky. So we're in that now. We're 12,000 years into this interglacial. We came out of an ice age about 12,000 years ago. That's what made modern agriculture possible in the Mideast and so on. That's when they started growing wheat, corn, those grains, barley, beer. I'll just give you a heads up. The beer price is going to shoot up when barley gets wiped out. So enjoy your beer while you can. So what do we see here? Here's the interglacial we're in now. There's 1, 2, 3, 4 back, and that's 400,000 years. So every 100,000 years, there's an ice age and then an interglacial. So the ice age is most of it. You see it starts to come down, then it crashes down, and it slowly gets colder and colder. Then it shoots up again. It takes about 5,000 years from here to here. So that happens slowly by human timescales, but fast on a geological timescale. So every 100,000 years we've been in this cycle. Now this is 500,000 years back about, and it continues like this back for 1,000,000 years. Then before that, there was a different cycle going on. This is a 100,000 year cycle. There used to be a 40,000, 41,000 year cycle. It was faster. And that went on for about 2,000,000 years farther back. And before that, there was another cycle. Now you say, why? What's causing these cycles? This is called the Milankovitch cycle, and it has to do with the orbit of the Earth, and mainly the eccentricity. When the Earth's orbit is slightly unstable. Now, it doesn't wobble a lot, but it goes from being very circular to slightly less circular, slightly more elliptical. And when it's circular, we have the interglacials, and when it gets more elliptical, more oval-shaped, then we get an ice age. So the Earth is going, it's switching back and forth from these states, and that's what's causing these ice ages. Okay, that's over a long period. You see the pattern. And now let's look at a short period. Only 2,000 years. This is now 2000. We're 2020 approximately. And here we are. We go back to zero, to the Common Era. What's happened historically here? Here's the American Empire, starts where, say, around 1900. That's when Roosevelt sent the Great White Fleet around the world to declare that the U.S. was an imperial power now. So we have, this is the American Empire right here. Well, what a coincidence. I'll get back to this. Okay, we go back. Here's the British Empire. Here's the Dutch and Spanish and Portuguese and so on and so on. Middle Ages, the Ottoman Empire. We go back all the way to the Roman Empire here. But what do you see here? Well, you see some fluctuation there, but now look at this temperature scale. This is only 1 degree from, say, from the coldest here. Oh, by the way, these different colors are different methods of measuring the temperature. They're in broad agreement, but you can see they're not precise agreement. They include tree rings, ice cores, carbon isotopes at the mid-Atlantic Sea, where the seafloor is spreading. That tells you, anyway, there's various methods here, but they're all in broad agreement. Now, there was a rise here. The temperature range, you see, from the coldest down here, about minus 0.6 degrees, up to, say now, is about 1 degree Celsius. So that's the rise we've seen lately. This temperature scale is much expanded from the previous slide, where we saw 8 degrees in the graph. So these are very small variations. And they call this the hockey stick graph because it looks like a hockey stick. It's kind of straight along here and then whoosh, shoots up. Okay. Now this ended at 2004. We're now 2018. And we have now gone up somewhere up like here. So this rise has continued up steeply. Now let's look at the last 2 centuries. This is since your grandfather was born. This is recent times. Again, here's the timeline. So 1880, that's after the Industrial Revolution is well underway, but they weren't burning that much oil. You know, Rockefellers took over the oil industry in 1860s, was it? I don't know, sometime around then. Civil War times. And then we come up 1900 through the 20th century. We get into the 21st century here. Now we are here. And what do you see? You see it's kind of bobbing. Again, this is, what's the scale here? Here's 0. These are actual temperatures in Celsius. So this is 0, and there's 1 degree. Temperature anomaly, not the actual temperatures. The difference from the 1880 to 1920 mean. So 1880 to 1920, you take the mean of this period. That's what they're calling 0. So they're saying that's the starting point. Okay, so we start there at 0. You're bobbling around, you're up and down. And then it starts to climb. In the 20s, 30s, it goes up. Here's World War II. Drops off. I believe this was due to a big volcanic eruption in the 40s, which put a lot of dust in the atmosphere, cooled the world off for a couple of years. And so it slowed it down. But then 1970, look what happens. From there, it's almost a perfect straight line upwards until, here's 2000, 2010, until 2013 or 14 here. Whoa! We've never seen anything like this before. So the last 4 years have been dramatic. This is what has the climatologists freaked out. This was last year, and you're going to say, what's this year? This year is down slightly. Now, there's another pattern that we should mention overlaid here. There's the El Nino last 3 or 4 years. That's when the Pacific circulation changes a little bit, and the ocean releases heat into the atmosphere. And then you're followed that by what they call La Nina. That's the opposite, when the atmosphere cools down again. So there's a natural variation over about 4 years, about 4 years for each section. So we are now into La Nina, which is supposed to be cooler. It is indeed cooler. It's right down about here, but not much. You can see we've got 1 to 2 years left of La Nina. Then we go back to, we start the next El Nino. And then I expect to see something like this again, going up 1/10 of a degree per year. It's mind-boggling. Okay, now what's the projection? This is the data, the black line here. Again, where temperature change is a little confusing. This is in Fahrenheit. Remember, so 1 Celsius is 1.8 Fahrenheit. So when they talk these numbers here, 2, 6, 4, 5, and so on, those are in degrees Fahrenheit. And you can do the math in your head, but here's the line. This is this is 1950 to 2000. Here's 1970, about there. That's where that straight line up starts. And here's where we are now. Now, these are 3 projections for the future. This one is already toast. Forget about that. So we're choosing between this and this. So that means by end of this century, we are up in Fahrenheit about 4 degrees Fahrenheit, or as high as 8 degrees Fahrenheit. You don't have to be a climatologist to understand what an 8-degree Fahrenheit hike on this planet would do to the grain belt, for instance. Okay, now some consequences that are already happening. Just a couple here, quick ones. Sea ice. Here's the Arctic ice cap, and this is in September of each year is when it reaches its minimum. That's the hottest time of the year. Most of the ice is melted. All of it's going to melt that year, and then it cools off in October, and it starts to expand and grows through the winter. So this is September 1984 and 2016. That's 30 years, and it doesn't take a rocket scientist to tell that the ice is disappearing. Exactly how fast is it disappearing? This was, again, the same time frame, 1980 to 2015. This is millions of square miles of ice in the Arctic. So we were at 3 million square miles 30 years ago. It bobbles around, but you can see the trend is very clear. We are now at about 1.8 million square miles. So we've lost 1.2 out of 3. That's 40% gone. That understates the problem because that's only the area. The ice has also gotten much thinner. You can see here on this last slide, this little sidebar here shows you that, you can't read this probably, but it's ice area by age. So it used to be mostly multi-year ice that stayed there year after year, and the top would thicken up and then melt and then thicken every year like that. But most of it stuck around. Now compare that to currently, almost no multi-year ice. It's very thin. So if we've lost 40% of the area and we've lost, say, half the thickness, then we've lost 80% of the ice. So that puts us another quarter of that time, of that 30 years, 35 years is 8-10 years. We're looking in the next decade to see an ice-free Arctic. That hasn't happened in 1 million years. So we're moving into new territory. ExxonMobil wants to take advantage of this and go in and start drilling for oil. Sea ice extent, okay, we covered that. And here's hurricanes. This is present day. We get 244 Cat 4 to 5 hurricanes every year. Late 21st century, that's 50, 60 years from now, we're going to get 313, according to computer simulations, 4 to 5. And the pattern changes. And this first one, you can just barely see Hawaii here. And you see, we get a free pass year after year. We always get these warnings, hurricanes on the way, it goes north, it goes south. It very rarely hits the islands. In the last 50 years, I've seen a graph. There's been one, I think, in 50 years, half a century. Now, compare that to, where are we? Where's Hawaii? Right there. So now we come down here. We've got to measure from this stuff down here. So we're right about there. I can't even see it. We're buried in Cat 4 and 5 hurricanes 60 years from now. Multiple per year hitting the islands, direct hits. That's the prediction. Hard to pronounce this, apocalypse. A very beautiful bug. Isn't that a pretty color? Looks like you'd like to take it home as a pet. This paper just came out a week ago. Puerto Rico has lost as much as 60-fold of their insects in the last couple decades. 60-fold. That's down to, from 100% down to about 1.5%. Somewhere between 10 and 60-fold. So somewhere between, we're down to 2 to 10% of what there used to be. So we've lost over 90%, maybe 98% of the insects are gone now. The frogs, of course, are dead too, because they have nothing to eat. The birds. The whole web of life is collapsing in the Costa Rica, did I say Puerto Rican rainforest. This is in a protected rainforest. There are no mines. There are no cattle ranches. There are no logging enterprises going on. None of that. This is protected area. This is purely a result of the temperature rise. It's gone up about, it's gone up more in the tropics, about, well, we're 2 degrees Fahrenheit, and it's more than that in the tropics. So, this isn't just Puerto Rico, it's worldwide, but this is a paper that just came out. One prominent entomologist said, this is the most terrifying science paper he's ever read. Okay, tipping points now. Let's get on with this. So here we have a list of possible tipping points. Remember, these are feedback loops. Once you trigger them, you can't stop them. They're running on their own after that. So we got 3 ranges. They could say 1 to 3 degrees, 3 to 5, and over 5. So the 1 to 3 is the yellow. Here's the yellows, these here. Mostly ice sheets melting. The Greenland ice sheet, Arctic summer ice, alpine glaciers, West Antarctica. Coral reefs are toast too. If we go over 2 degrees, they say 99% of the coral on the planet is gone. It can't take the heat. If we go into the 3 degree range there, you get those orange ones. That's these. Now, okay, what is the feedback loop here? It's like we said, if you melt the ice, you stop the reflection, you absorb more heat, you melt more ice, more heat, more ice. It goes on. Okay, the orange one here, these are mostly circulation issues. Well, the Amazon rainforest is gone. Like I said, we just talked about Puerto Rico. That's just the tip of the iceberg. The whole Amazon could disappear, could become a savanna. That would be a huge loss biologically. Most of the species on the planet are in the Amazon. So we lose the jet stream. We lose the El Nino oscillation stops. We lose this thermohaline. This is salt, and this is the current that goes up past Europe from the south here, and keeps Europe temperate. If that circulation system shuts down, then Europe goes into an ice age, and you can't grow crops there anymore. It's unimaginable what we're talking about here, but that's what the projections say. Okay, if you get to 5 degrees centigrade, that'd be up in the 8-9 degrees Fahrenheit range. Nobody's even speculated about anything beyond that, but that's conceivable. Yep. 5. Here we go. East Antarctic ice sheet could go. That's the big boy. This is the big one. If we lose that, it's bad news. Arctic winter sea ice. Let's move on. Those are the problems. Okay, what do we have to do about this? Here we are now, 2017. This is last year. This is the time, and here's how much CO2 is emitted globally per year. This is in gigatons. That's 1 billion tons. So in 2010, we had 38 billion tons emitted. 7 years later, last year, we emitted 41. We're still climbing. As we speak, CO2 is increasing. Although all the governments have agreed to bring it down, it's not happening. So we're just going up. This is a projection, 2030. This is what they just said has to be done to stop us at 1.5. And by 2050, 0. We got to be completely fossil fuel free. Is this going to happen? What do you think? Okay, 2 slides. Here we go. Temperature, this is the projections of the pattern, the loop we're in. So here's temperature, that's hotter, colder. Here's +2 degrees. That's the red line we're trying to avoid. Here's sea level rise and so on. This is the pattern we've been in for the last million years. We go into an ice age. The sea level drops because the ice freezes. It takes water out of the ocean. We get colder and colder, and finally that stops. Then we come back around, and the temperature starts to rise, and then the ice starts to melt, and the sea comes back up. This has been going on for a million years. Now, we moved out of this loop. We've moved up here. We're at 1 degree and rising fast. And if we don't do anything, if we just continue business as usual, we will go into hothouse Earth loop. It gets very hot. The ocean rises dramatically, wipes out coastal cities, and the world civilization is hammered. I'm not saying the last human being will die, but a lot of people will die, and we will get set way back in our development. What we would like to do is stop this now and make this a small loop and get back into our old loop. Actually, if we manage to do that, then once we know how to manipulate things and get organized on that scale, we probably don't want to go through another ice age either. So we'll probably try to keep ourselves in a little loop right around ideal conditions like now. Okay. Another plot of the future. This is time coming forward. Here's cold and hot, and this is stability. We've been going back, ice age, and back here, interglacial back like this in history for the last million years. But now we're swinging over here. We're moving up hotter, out of the normal hottest temperatures we've had. We're going beyond that now. If we keep emitting CO2, we're destroying the biosphere, and then at some point we get into a feedback, then we plunge over the edge, and we get really hot. Last statement. This is what's going to get me in trouble with somebody, but I got to say it. This ruling class's material interest is rooted in fossil fuel. It will tenaciously resist change, like they have for the last 50 years. In 1968, Edward Teller gave a talk to the American Petroleum Institute, where he laid out what was coming. They ignored him. The next year, they gave the API went to Congress and gave a talk. They buried it. They've been burying it ever since. Not only burying it, they've been putting out this big disinformation campaign, $200 million worth in the last 20 years, to deny that there is such a thing. It just reminds you of tobacco. Back when they first said tobacco is dangerous, the tobacco companies poured huge amounts of money into fighting that belief, to tell everybody, no, it's not that bad. The oil company's doing the same thing. I think I'm maybe if John Dvorak is watching this, he congratulated me last year on maintaining my objectivity and not taking sides. Sorry, John. I have now swung over to the pessimist side after these latest results. This is what I personally believe. Effective opposition will not be organized in time to stop the ruling class, the American ruling class. They've been in power for centuries. They are not going to let go. There's no record ever in 6,000 years of empires of a ruling class voluntarily giving up its wealth and power. It's never happened. You have to force them to do it. And that means that we have numbers. We're the population. We are the people. We have the power. Can we organize to use it? We have the technical ability and financial resources to stop climate change, but class division renders us politically unable. That's my sad conclusion. Sorry.